Hello everyone, this is Sumit Kumar, and what I'm going to do in this video, I'm going to solve some questions in application of Lagrange's mean value theorem. From last I think 3 months I got lots of mail regarding to do this kind of problems. What happened? This kind of questions are important in your competitive exam, right? If you are going to write IITJAM or NET JRF, let's say NBHM and TIFR, right? But the most important part is this is so basic, one should know that, okay, this is the mean value theorem, this is the Lagrange's mean value theorem statement, and this is the proof. But how one should apply to a question, if certain question is asked about to check your knowledge of Lagrange's mean value theorem, how one can apply that knowledge so that you'll be very confident and you will get that answer. So that's what I'm going to do with this question. This question is, very important, very important, particularly for the candidate who are going to write JRF exam, particularly for the candidate who's going to write TIFR exam, right, or JAM as well. So it's my humble request, so go through the basics first of all, and then you should understand what I want to say. Okay, so without wasting a fraction of a second, let's try to understand what this question exactly says and how one should approach this kind of problems, right? So question is, so this question is important for your exams like NBHM, TIFR, or NET JRF, all those. So here is question. So question is, F is a mapping from R to this compact set minus 2 to 2. So F is a real valued function. What kind of function? This is twice differentiable function. What do you mean by twice differentiable function? So let me recall again. F is a function from the domain R with the codomain minus 2, say 2, with the condition that it is twice differentiable function. With the condition, the value of f at 0 and the value of derivative at 0, if you take the square and sum it, you will get the value 85. Okay? Then the question is, then they are saying there exists alpha from minus 4 to 4 such that f alpha plus f double prime alpha is equal to 0, but f prime alpha is not equal to 0. So this question is like very basic. Let me again say what is the question exactly. Let's understand the question first. F is twice differentiable with the condition the value of functional value at 0 and the derivative at 0 plus square plus sum is equal to 85. Then you have to say whether this statement is true or false. And what is the statement? Can you find alpha from minus 4 to 4? Right? Alpha ko kahan se nikalna hai? Minus 4 to 4 with the condition that f alpha plus f double prime alpha is equal to 0, but derivative of f at alpha is not equal to 0. See, these kind of stuffs are very favorite. Doesn't matter you are going to write NET or JAM or NBHM or TIFR. This kind of questions are very important. So I request you should go through it what the question is exactly saying. So how one should approach, how one should learn to do this kind of answer, right? So I always start how to think this kind of problem, how to think, how one should approach this kind of problem, right? So this is the typical application of Lagrange's mean value theorem. This is the typical example of applications of Lagrange's mean value theorem, right? I'll state here. So let me first recall. So first recall the basic facts. What are those basic facts? So the basic facts is very simple here. If f is a mapping from your closed interval AB to R, okay? F is a mapping from AB to R which is continuous on AB, okay? And differentiable on open interval AB, okay? Then there exists C in open interval AB such that f prime C is equal to fb minus fa minus 1. Correct? So this is the Lagrange's mean value theorem. So what is the Lagrange's mean value theorem states? Lagrange's mean value theorem says that if you have a function from closed interval AB to R, that function is continuous on closed interval AB, and differentiable on open interval AB, then you are able to find some point in open interval AB with the condition that derivative at C is nothing but the difference of these two. And it is very easy. Proof you can find in any standard book. So proof of this I'll give as an exercise. So please go through the proof so that you will understand what exactly this theorem says, what this Lagrange's mean value theorem says. So this is nothing but this called Lagrange's mean value theorem, LMVT. Okay? The statement, the shortcut name is LMVT, Lagrange's mean value theorem. So it's my request to you, first you should know this. What is this? Okay? So I'm erasing it. I hope you know this. So I'm going to use this again and again. ठीक है? तो चलो ये सब क्वेश्चन को हम लोग कैसे इसमें डील करते हैं उस चीज को हम लोग समझते हैं. So what is given here? तो पहले क्वेश्चन को समझते हैं. What is the question? Question is you have given me a function from AB to R such that this f is twice differentiable. ठीक है? This function is twice differentiable. So here AB is nothing but your minus 2 से 2. So there is a function R say minus 2 say 2 such that f is twice differentiable. So function is your twice differentiable and that f0, value of f at 0 and derivative at 0 का square is nothing but 85. ठीक है? So these three facts they have given. Function is this, twice differentiable, and the value at 0 with its derivatives is this. Then the question is, does this imply there exists alpha in minus, can you find alpha from minus 4 to 4 such that, what is that? F prime alpha should not be equal to 0, but f of alpha plus f double prime alpha is equal to 0. So that is the your question. So first you should understand the question without rushing to solve the question. First you should know what is the question exactly, what they are asking. That is the first important thing. You know, होता क्या है क्वेश्चन का सॉल्यूशन उस क्वेश्चन में ही छिपा होता है. So आप लोगों को करना है थोड़ा सा एनालाइज करना है कि कहाँ पे क्या प्रॉब्लम है. What is the problem first of all? So function question is very simple. Twice differentiable, functional value at 0 and the derivative of square is equal to 85. 85 is not important, that can be any random number you can give, doesn't matter. Then can you find alpha from minus 4 to 4 such that derivative at alpha is not equal to 0 but functional value at alpha plus double derivative at alpha is equal to 0 because function is twice differentiable. Is it true or false? That's what they ask. ठीक है? So question समझ में आया? So इस question को समझने के लिए, इसको आंसर करने के लिए we should know the Lagrange's mean value theorem. We have already stated Lagrange's mean value theorem. Now apply everything to answer this question. ठीक है? तो चलो करते हैं. तो कैसे करें? ठीक है? कैसा शुरुआत हो? What will be our first step? Important is to take the step, but also we should try. The step should be in the right direction, right? ठीक है? So let's come here. So the question is, so let me apply LMVT in this interval, minus 4 to 4 on this interval. Apply this LMVT. So apply LMVT on this interval, minus 4 to 4. So since function is from R to minus 2 to 2. So of course I will apply the mean value theorem. So by LMVT there exists C in open interval minus 4 to 0. Of course my function on minus 4 to R, of course this is the function. If I approach, if I take the restriction of this function, if I, of course my function is from R to minus 2 to 2. So if I restrict my domain from minus 4 to 0, this is still the same function with the same given condition. Condition में कोई change नहीं होगा. So I'll apply my LMVT for this particular interval because to apply LMVT I need interval. And how I choose this minus 4 comma 0? Because that is the hint. That is the hint here. Hint is this. We need alpha from minus 4 to 4. So I'll go from minus 4 to 4, minus 4 to 0 and then 0 to 4. Minus 4 to 0, I'll get alpha 1. From 0 to 4, I'll get alpha 2. And let's manipulate something. Because I have to use the double derivative. To get the double derivative, something I have to apply. So let's see how I can go. So apply LMVT in this interval. There exists C from minus 4 to 0 such that what is going to happen? f prime c. F prime c is nothing but f0 minus f of minus 4 by 0 minus minus 1. That's my Lagrange's mean value theorem. Now calculate this modulus, right? So what is the modulus? Let me calculate this modulus. So modulus is f0 minus f of minus 4 by 4 का mod. Correct है? If you look at carefully, f0, the value of f0 is maximum 2 and minimum minus 2. And value of f of minus 4, maximum 2, minimum minus 2. So what is the maximum value of numerator? So this value is f of 0, take the positive, this by 4, correct है? So that is i.e. f prime 0 का mod is less than equal to, this value is maximum 2, this value is maximum 2 by 4, so this is 4 by 4, so this is equal to 1. So what we have shown, see, if I apply the Lagrange's mean value theorem on minus 4 to 0, I am able to find c on minus 4 to 0 such that derivative at c, the absolute modulus is maximum 1, right? So that's what. So let me write here. This whole summary, right? So there exists c1, let's call it c1, from minus 4 to 0 such that f prime c1 का absolute value is less than equal to. ठीक है? How? By elongating. ठीक है? By Lagrange's mean value theorem, whatever we have studied so far, right? Again, the same reasoning I can apply for this interval, right? है? Same reasoning. See, I have to find some alpha from minus 4 to 4. So I have reached so far 0 तक. अब 0 से 4 जाना है. So apply the same reasoning. So there exists C2 from 0 to 4 such that f prime of C2, the absolute difference is less than equal to 1. Again, how? This is elongated. ठीक है? By Lagrange's mean value theorem. Now I have to utilize this concept to answer this question. ठीक है? So I got C1 and C2 from minus 4 to 0 and 0 to 4. Fine है? Okay. So now, I have used the differentiability part, but not the twice differentiability part. Now I want to use this. I am going to use this. f0 का square plus f prime का 0 का square is equal to 85. So look at this function. Look at this function. fx का square plus f prime x का square. Look at this function. And what is my domain for this function? Of course, my x will belongs to your c1 to c2. Look at this. So of course, c1 is negative and c2 is positive. So x is, of course, it is well defined, right? So the function is very well defined. So my gx is this. Gx you can take fx square plus f prime x square, and x belongs to c1 to c2. Fine. What you can say about this function at all? What one should say? That's what one should absorb. You will ask, sir, how one can take this function? How one should think about this kind of function, that I have to choose this kind of function to answer my question, how one should think. So listen, the question, to answer this question is hidden here. You have to use somehow this function. So I have to write fx square plus f prime x square, something like that. Because I am going to use the compactness of the set. This function is continuous, correct? Look, see how beautifully I am going to use my compactness. This function is continuous and function is twice differentiable. So if function is twice differentiable, its first derivative is of course continuous. So this is continuous, so square plus square, this is continuous. So this function is continuous. This function is continuous on C1, C2. And what is given also? Z0. What is the Z0? Z0 ka choice is 85. So choose, think again. Look at this. This function is continuous. This function is continuous on C1, C2. How this is continuous? Because this is sum of two continuous function. How this is sum of two continuous? This is already continuous. and function is twice differentiable, hence the first derivative must be continuous, then I can take the second derivative. So this is continuous. So this function is sum of two continuous functions is continuous, and the value at 0 is 85. So, and this set, look at this set C1 C2. On C1 C2, so this function, if you look at, if you plot the graph, here is C1, here is C2, and C1 C2. This is -4, this is your +4, and here is your C1, here is your 0, here is C2. So at 0 पे function की value कितनी आ रही है? 85. So functional value of f is 0.5. अच्छा, let me erase this and let's make it more clear. ठीक है? Okay. Right here in the process. So what I have done so far, so construct this function, define this function, this fx square plus f prime ka whole square, and of course my domain x belongs to C1 C2. Correct hai? So is so this is your -4, this is your 4, and this is your 0, and here is your C1, here is your C2 by our construction. And what is the C1 C2 का rule? C1 C2 का ये definition था, f prime at C1 का maximum value is 1 and f prime at C2 का maximum value absolute modulus is 1. That was the relation of C1 and C2 with our function. And clearly this function is continuous and differentiable. Correct है ना? On this interval C1 C2. Of course my function is differentiable over R. So restriction of differential function on subsets of R is also differentiable. It's not a big deal. So this is differentiable, and this is my compact set, and my C1 C2. This is compact. So what is the relation of continuity and a compact set? Yes, you can say. What is the relation between continuity and a compactness? So relation of continuity and compactness is any continuous function on a compact set attains its maximum, right? And attains its infimum. I'm interested here maximum because the functional value at 0 is achieved. Functional value, what is the functional value at 0? Is nothing but 85 that we have given, right? And g of C1, what is g of C1? So g of C1 is nothing but f of C1, correct है? f of C1 का square plus f prime C1 का square. What you can say about the g of C1 का value? f of C1 का maximum value, see f का maximum value can be 2 modulus. So इसका square maximum value will be 4 and इसका maximum value is 1. So this value is 5. So g of C1 is less than equal to 5 and g of C2 is less than equal to 5. Correct है? So हमारे पास एक ऐसा continuous function है जिसका end points में value 5 से ज़्यादा नहीं है और वो नॉन नेगेटिव है, और एक मिडिल पॉइंट पे ये जो 0 पे जो इसका वैल्यू हो रहा है वो 85 हो रहा है. So let me erase this part. So G is continuous, so there exists alpha from C1 to C2 such that G alpha is equal to sup of G of x belongs to C1 to C2. करेक्ट है? सो एक फंक्शन मिला हमें, एक ऐसा फंक्शन मिला C1 C2 के बीच में जिसका एंड पॉइंट्स पे जो वैल्यू है वो 5 है, एंड पॉइंट्स पे वैल्यू मैक्सिमम 5 है और 0 पे वैल्यू 85 है. तो यहाँ से ये पता चल गया कि जो मैक्सिमम अटेंड होगा वो C1 C2 के बीच में अटेंड होगा. करेक्ट है? C1 C2 के बीच में अटेंड होगा. C1 C2 पे मैक्सिमम नहीं अटेंड होता क्योंकि एक अंदर वाले पॉइंट पे, इंटीरियर पॉइंट पे ऑलरेडी फंक्शन का एक वैल्यू मिल रहा है 85 और एंड पॉइंट्स में वैल्यू है वो 5 से ज़्यादा नहीं है. तो दैट मीन्स मैक्सिमम विल बी अटेन्ड इन द इंटीरियर पॉइंट. इंटीरियर पॉइंट का मतलब अंदर वाले पॉइंट पे मैक्सिमम अटेंड होगा. तो अगर कोई फंक्शन डिफरेंशिएबल है, रिकॉल अ फैक्ट, इफ अ फंक्शन इज डिफरेंशिएबल ऑन लाइक ओपन इंटरवल ए बी और उसके किसी पॉइंट पे, इनसाइड वाले पॉइंट पे वो मैक्सिमम अटेंड कर रहा है, तो उस पॉइंट पे फंक्शन का डेरिवेटिव क्या होगा? 0. That's a local maximum minimum theorem, right? So recall a fact. So recall, if F, let me write this H is mapping from AB to R, continuous and differentiable on AB, and H attains maximum at alpha in open interval AB, then derivative of at H alpha is equal to 0. So recall this fact. This fact I am going to use. Okay? So using this fact, what I am saying is, if F is mapping from AB to R, continuous and differentiable on open interval AB, and of course function attains its maximum value because interval is compact. So if a continuous function जो maximum value attain हो रहा है, and if that point lies in the interior point, then derivative at that point must be 0 if function is differentiable. So using that, derivative at that point must be 0. So same case will arise in our case. Function maximum value is attained inside C1 C2 because C1 C2 के maximum value 5 और 0 के value 85. So C1 C2 must be alpha must be interior point. Therefore, that implies that fact derivative at alpha must be 0. Let's compute the derivative. That implies what is the derivative? 2 times f of alpha plus f alpha plus 2 times f prime alpha into f double prime alpha, that's equal to 0. You can take 2 bahar, so f prime alpha you can take common, that's equal to f alpha plus f double prime alpha, that's equal to 0. Now from here what you will say? F prime alpha, this product is equal to 0, so either this equal to 0 or this equal to 0 because this is the product of 2 real numbers, right? So either this may be 0 or this may be 0. What you will say? This can be 0. If f prime alpha can be 0, अगर f prime alpha 0 हो गया, so this is 0. So z alpha is equal to f alpha का square. और f alpha का maximum value कितना है? f alpha का maximum modulus का maximum value कितना हो सकता है? 4. So g alpha can be maximum 4. और हमें पता है कि जो alpha होगा वो of course मेरा 85 से बड़ा है. But f prime alpha cannot be 0. So अगर g alpha 85 से बड़ा होगा, that implies f prime alpha cannot be 0. So g alpha चूंकि 85 से बड़ा है क्योंकि 0 पे वैल्यू 85 होगी, तो मैक्सिमम जो होगा वो एटलीस्ट 85 होगा. So f prime alpha कभी भी 0 नहीं हो सकता क्योंकि f prime alpha अगर 0 हो गया तो ये क्वांटिटी मैक्सिमम वैल्यू देगी 2 और 2 का स्क्वायर 4, तो g alpha का मैक्सिमम वैल्यू 4 होगा. बट वो पॉसिबल नहीं है क्योंकि g alpha का मैक्सिमम मिनिमम वैल्यू 85 होगा. Hence f prime alpha must be non-zero. That implies f alpha plus f double prime alpha is equal to 0. So this is the logic to answer to this kind of problem. You know, so simple question how I have done. So let me recall how I have done. I have used the Lagrange's mean value theorem thrice. Right? One, I got the C1 minus 4 to 0, then 0 to 4. Then I constructed this function. How I constructed, what that notion keeps me to define this function. This was the hint. So this I keep that. And then I go through the process of differentiation. I am able to construct this kind of answer and able to do this. So that's what I say. Every question answer knows question में छिपा होता है. अगर question थोड़ा सा tough है ना, that means the question is very basic. It's so elementary. That means your elementary part is not good. You have to focus on your elementary part. Important is that. Okay? We are always rushed to go to study higher things, but we forget that okay, our basics are not good, and it's not a crime. If your basic is not good, it's not a crime. We have chance to learn the basic at the ground level. So that's my interest. See, I use the elementary part to answer this kind of question. I have not used so much complicated. Just one standard thing I have used was the compactness, continuity and compactness. Still I am able to answer this. That's what I'm saying. Think about it, how one should answer this kind of question to approach correctly. Right? So for me to give the answer, it's not a big deal. But to make you comfortable in this subject is for me like a big challenge. I want to make every small things little larger, whatever you think that so-called very tough cheese. I want to make it asan by giving such examples. So this is the example, okay? So thank you for watching video. And one more thing I wanted to make an announcement. Thank you for watching that. My videos really means a lot. And if you have not subscribed my YouTube channel, please subscribe it. And it's not too late, trust me. If you are still wanting to learn mathematics, still your goal is to qualify NBHM or TIFR, or your dream is to go to any still you should come. I mean, I am ready to help you. Okay, so thank you for watching my videos. It really means a lot to me. Thank you so much.